Shri Sai Ram. In the previous session, we learnt how to find the adjoint of a square matrix, and today we will do some more problems from exercise 4.5. So, continuation to that is, so yesterday we have done two problems. So, here do you remember this? We have given this statement in one of the theorem in the previous session, and we have to prove that statement through an example. Here we have a square matrix of order 2, and we have to show that A into adjoint A is equal to adjoint A into A is equal to determinant A times I. That is what we need to prove in this. So, for this I am going to consider, I will consider this given matrix as A. Let A equal to 2, 3, minus 4, minus 6. Okay. For this, I need to find adjoint of A. Before finding adjoint of A, we should find cofactor. After finding cofactor only, we need to find adjoint of A by taking the transpose of cofactor matrix. Understand? So, for this I can write cofactor matrix. Cofactor of A is equal to, say yesterday in the last class I told you to write how to write the cofactor matrix in a shorter way. No need to write all the elements of cofactor. So, you can directly find out the elements of cofactor matrix here. So, what you can do is plus, minus, minus, plus. Okay. For this, what you can do is, see, this is the element which lies in first row, first column. So, how you can find that element from the given matrix is, you just delete the first row, first column of the given matrix, and if you delete, so first column and first row, what do you left? Minus 6. Okay. Similarly, we can find that entry as well. So, how you can find that first row, second column? You just delete the first row and the second column. What you left? We have minus 4. Similarly, for this. So, first column, second row, 3. For that, second row, second column, 2. Then how you can find adjoint of A? You just take the transpose of the cofactor matrix, that gives adjoint of A. Adjoint of A is equal to, you take the transpose of that matrix. What is that? Minus 6 minus into minus plus, which is 4. This is the first row is what? Minus 6 plus 4. I will write that first row as first column here, 4. Next, minus 3. Second row is what? Minus 3 and 2. I will write that in a second column, right? So, 2. This is what? The adjoint of A. Then what we can do is, we can find what A into adjoint of A. So, how you can write that is, A into adjoint of A is equal to, what is A here? 2, 3, minus 4, minus 6 into adjoint of A. What is adjoint of A? Minus 6, minus 3, 4, 2. So, you just multiply this and give me the product matrix. So, 2 into minus 6 is minus 12, 4 3 is plus 12. See, you know the matrix multiplication. So, minus 6 and plus 6, and here, so 4 into 6, that is 24, minus 4 into minus 6, plus 24, and minus 6 into 4 is minus 24, 6 fours are, and here minus 4 into minus 3 is plus 12, and minus 6 into plus 2 is minus 12. So, what is the matrix? The matrix is 0, okay. The value of that is 0 matrix, understand. I will denote it as 0 matrix. Similarly, you can find the adjoint A into matrix A is equal to, you just minus 6, what is adjoint A? Minus 6, minus 3, 4, 2 into A. What is A? Here 2, 3, minus 4 and minus 6. Just multiply. So, what you are going to have? So, what is this? Minus 12 plus 12 and 18 plus 18, 8 minus 8, 12 minus 12. What is the matrix? All entries are 0, right? So, 0, 0, 0, 0. So, 0. So, you can call it as 2, equation 2, that is equation 1 is also we got 0, as well as equation 2 is also 0. Now, we found out this, and now we have to evaluate this. How are we going to do that? So, you just determinant, how can you find determinant of matrix A is? So, you just take the determinant on both sides of this square matrix, you will get 2, 3 minus 4 minus 6 is equal to, what is this? 2 into minus 6 is minus 12, minus of minus what? 12. What is this? Minus 12 plus 12, understand? What is this? Minus 12 and plus 12 get cancelled. So, we got the determinant of the given matrix as 0. See, do you think is it matrix, inverse matrices exist for this given matrix A? No, it won't exist because the given matrix is singular, right? Yesterday we discussed, we defined the definitions of what is singular matrix and what is non-singular matrix. Understand, if the matrix is non-singular, then only we can able to find what is inverse of a matrix, right? So, here we got as 0, and we can find determinant determinant A into I is equal to, determinant is what? 0, right? So, and we have to take I. See, here we have to take the order of I as 2 because the given matrix is order 2. So, we have to, which is understood that we should take the identity matrix of order 2, right? So, what is the order of that? 1, 0, 0, 1. These are the, this is the identity matrix of order 2. If you multiply a scalar 0 with the given matrix, it will get 0, right? So, you can call it as 3. You look at equation 1, 2 and 3, all are zeros, right? So, by this we can conclude that adjoint A into A is equal to A into adjoint A is equal to determinant A into I. By this we can conclude that, hence that statement is proved. Okay. Next we have, similarly we will do the another problem. Yeah. Here we have one more problem, in the same way we have to do it, but here this matrix has 3 cross 3, okay. So, what is that statement we can have is A into adjoint A, this is a continuation of the previous problem, right. So, we have to show that A into adjoint A is equal to adjoint A into A is equal to determinant A times I. This is what we need to prove for this matrix, okay. So, for this what I am going to do is I will take the given matrix as A, okay. I will take A is equal to the given matrix, okay. So, now for this we have to find adjoint A, right. How can you find adjoint A? Before finding adjoint A, you better find cofactor matrix. cofactor of A is equal to, I think you are quite familiar with the signs which are associated with each element of the given matrix, right, or any matrix of a square matrix. Okay. So, what is the signs which are associated with each element? The matrix is square. Okay. Plus, minus, plus, next minus, plus, minus, plus, minus, plus. So, with this what you can do is, how are you going to find this element? You just delete the first column and first row from the given matrix and you can able to find that. Okay, what is that? This is what first column and this is first row. If you delete so, understand, and take the determinant of these elements. So, if you do so, what is the determinant of the 0, minus 2, 0, 3? What is the determinant value? 3 into 0 is 0, minus 2 into 0 is also 0. So, the entry is 0. Okay. Like that you can find entries of all the elements. Okay. So, we will see that. So, now this one, where this element which lies in this matrix. So, first row, second column, you just delete and take the determinant of other elements, 3, minus 2, 1, 3. Okay. Understand? I am just deleting this, 3 minus 2, 1, 3. What is that? 9 plus 2. What is the answer? 11. Understand? 3 into 3, 9, minus of minus 2, which is plus 2, and the answer is 11. Similarly, this, what is this? You just delete the first row, third column, 3 into 0 is 0, minus 1 into 0 is 0. This entry is 0. Okay. Next is this. Now, this entry which lies in first column and second row, and you just delete the first column and second row and take the determinant of other elements. Okay. So, what is that? Minus 1, 2, 0, 3. So, what is that? Minus 3, minus 0. So, what is the entry is minus 3. Okay. Next, now this element which is in second row, second column. Okay. And take the determinant of other, 1, 2, okay, 1, 3. What is this? 1 into 3 minus 1 into 2. So, the answer is 1. Similarly, this third column, second row, 1 minus 1, okay, second row, third column, 1 minus 1, 1, 0, okay. What is this? 0 minus of minus 1, the answer is 1. So, this entry is 1 now. Similarly, you can find other 3 as well. First column, third row, and take the determinant of other elements which is there. After deleting first column, third row, minus 1, 2, 0, minus 2. So, 2 minus 0, 2. So, you put on 2. Next, second column, third row. So, take the determinant of other, 1, 2, 3, minus 2. Understand, I am deleting the second column and third row. And other elements I have took it as in determinant form, that is minus 2, minus 6. So, minus 8. Understand, 1 into minus 2 is minus 2, minus 2 into 3 is 6. Okay. This into this minus this into that. Okay. So, 8 minus 8. Next is, so what you can do is you delete this third and third row and third column, 1 minus 1, 3, 0. So, this is 0 plus 3. Okay. Why plus 3? Because 1 into 0 is 0, minus 1 into 3 is minus 3, minus of minus 3 is plus 3. So the answer is 3. So you write down 3 here. Now I can able to write adjoint of A. What is adjoint of A? You take the transpose of this matrix 0, minus 11, 0, 3, 1, minus 1, 2, 8, 3. This is the adjoint of matrix A. Okay. Now we try to find this. What is that? A into adjoint A is equal to, what is A? A is 1 minus 1, 2, 3, 0 minus 2, 1, 0, 3 into adjoint of A 0, 3, 2 minus 11, 1, 8, 0 minus 1, 3, which is equal to, you just do the matrix multiplication here. What is that? 1 into 0, 0 plus 11, okay, 2 into 0, 0. I can do it directly. So if I write down that in detail, step by step, you may come to understand. So now this first row, second column, to find this entry, 1 into 3, 3, minus 1, minus 2. What is that entry? Becomes 0. 2, minus 8, plus 6. What is that entry? Becomes 0. 3 into 0, 0, plus 0 into minus 11, 0, minus 2 into 0, 0. Next, 3 into 3 is 9, 0 into 3 is 0, okay, this into this, plus this into this, plus this into this, plus 2, okay. Next, 3 into 2, 0 into 8, minus 2 into 3, minus 6, alright. So next, 1 into 0, 0 a minus 11, 3 into 0. Next, 1 into 3, 0 into 1, 0. 1 into 3 plus 0 into 1 minus 3 into minus 1 is minus 3, this is 0. Next, 1 into 2, 0 into 8, 3 into 3. See what is the matrix? The matrix is 11 and 0, 0, yes, 0, this one, 11, this one, 0, 0, 0, this one, 11. So this is my matrix, okay. Next, I need to find adjoint A into A. How are you going to find this? Similar way, okay. You take the matrix adjoint A. What is adjoint A? 0, 3, 2, minus 11, 1, 8, 0, minus 1, 3 into matrix A, that is 1, minus 1, 2, 3, 0, minus 2, 1, 0, 3, okay. So you just multiply and give me the answer. What is that? See, 0, 9 plus 2, 11. Next, 0, 0, 0. This one, 0, minus 6 plus 6. Minus 6 plus 6 is 0. This one, minus 11 plus 3, 8. 8 plus 3 is plus 7 and already minus 11 is 0. Minus 11 plus 11 will get 0 and here 11, 0, 0, 11 and here 11 minus 11, 2, minus 22 and 1 into minus 2 is minus 2. 8 3 is a 24. Okay. So, that's also get 0. Understand? Minus 22 minus 2 plus 24. Okay. What is that? Minus 22 minus 2 plus 24 is what? Minus 22. Okay. 0. Understand? That this entry I am telling. So, this is steps that is involved to find this element. Okay. Next 0 minus 3 plus 3 0 and here 0 0 0 0 plus 0 plus 0. Next 0 2 plus 9, 2 plus 9 11 and I can call it as you call it as 1, call it as 2. Look at equation 1 and 2, both are equal. Yes, both are equal. Now we got these 2. Now we need to find this. For that we need to find the determinant of A. Understand? So for that I'll rub this. Yeah, determinant of A. How can you find determinant of A? As you know that take determinant on both sides of the given matrix 1 minus 1 2, 3 0 minus 2, 1 0 3. Okay. What is this? Determinant means you will get one value, that's all. So 1. I think you better see, look at this. You expand this determinant along second row, second column. So what is that? If you do so, what are the what are the signs which are associated with these elements is plus, sorry, this is minus, this is minus, this is minus, this is plus and this is minus. Okay. So, minus of minus 1 into this entry becomes 0, this entry becomes 0. Okay. And you delete the first column, first row, second column and you multiply this 2. What is that? 9 minus of minus 2. What is this? 9 plus 2, 11. So, now my determinant value is 11. So, you multiply that 11 with identity matrix. So, you have to take identity matrix of order 3 because the given matrix is having order 3. Okay. So, that we have to, that is understood. So, we have to take identity matrix of order 3. So, now I will take determinant A into I is what? This is determinant A into I is equal to, okay. What is determinant value? Is 11. Now, what is matrix? What is identity matrix? 1 0 0 0 1 0 0 0 1. Multiply this, you are going to have 11 0 0 0 11 0 0 0 11. I will call it as 3. Now, look at equation 2 1 2 3. So, all the matrices are equal in all 3 equations. By this we can say that this statement is proved. Understand? So, we will move on to the other kind of examples. We will see the next example. See, do you understand? So, if the matrix is singular, so we can't able to find inverse. If the matrix is non-singular, we can find the inverse of the given matrix. Understand? Because their determinant cannot be equal to 0 in case of non-singular. In case of singular, the determinant becomes 0. Yeah, here particularly they have mentioned that find the inverse of the following matrices if exist. Understand? If exist means what? First we should check whether it is singular or non-singular, whether it is determinant or whether it is determinant is 0 or not equal to 0. That is what we have to check to get to know that whether inverse is exist or not. See, as I said in the first example, see, if you find the determinant, it will get 0, right? And this matrix does not have any square inverse matrix. Okay, this cannot be an invertible matrix, understand? Yeah, how are you going to find the inverse of this? If exist only we can find inverse. Okay, how are you going to find that? I'll take the given matrix as A, capital A, that is 2 minus 2, 4, 3. Now what you can do is, I'll find the determinant, okay, for this. Determinant A is equal to determinant of 2 minus 2, 4, 3, okay. What is the answer? 6 minus of minus 8. 4 minus 2 into 4 is minus 8. So the answer is, what is the answer? 6 plus 8. 6 plus 8 is 14, okay. Next we got determinant. Determinant is not equal to 0, thereby inverse is exist, understand. So that we can find inverse. Before finding inverse, we have a formula, right? So in the last class we have discussed that A inverse is equal to 1 by determinant of A into adjoint of A. Okay, what is adjoint of A? Just now we learned. Okay, so now find adjoint of A. If you find adjoint of A, that gives the inverse of a matrix through a formula there. See, now cofactor. How can you find cofactor of A? Cofactor of A is equal to, as you know that you just put plus, minus, minus and plus. So for this 3, 4, minus 2, 2. How I written? Delete this first column, first row 3, and this delete second column, first row 4, and this delete second row and first column minus 2, and this delete first second column second row 2, and for adjoint, to find adjoint of A is equal to, take the transpose of this 3 minus 4, 2 and 2. Okay. Now what you can see here, so we got adjoint, then by formula we can say 1 by determinant of A into adjoint of A is equal to 1 by 14, the adjoint is 3 2 minus 4 2. Okay, this is the inverse of a matrix. Yeah, this gives the inverse of the given matrix. And similarly, this is order 2. Similarly, we can find for order 3 in the same manner. Yeah, find inverse of the given matrix if it exists. So for that, I'll take the given matrix as A. I'll considering let A is equal to this matrix. So what I can do is, I can find determinant of A. What is determinant of A? See, one thing have you observed is, if you take determinant of this matrix, what we have is 1 2 3 0 2 4 0 0 5. Understand? See this, yeah, below the diagonal elements are 0, all are 0. So we can use the property, right? If the above diagonal elements or below diagonal elements are 0, then the determinant will be the product of diagonal elements. So what is the product of diagonal elements here? 1 into 2 into 5. What is the 10? So we got 10 is the determinant, and 10 cannot be equal to 0. Therefore, the given matrix is singular. Hence, we can find inverse. Okay, before finding inverse, we have to find cofactor. Cofactor of A is equal to plus, minus, plus, minus, plus, minus, plus, minus, plus. Here we can do that. So, you just delete the first row, first column and take determinant of 2, 4, 0, 5. What is this? 10 minus 0. Answer is 10. Here is 10. Next, similarly, you delete first row, second column. Take the determinant of 0, 4, 0, 5. Answer is 0. Next, here also that get 0 and this first column, second row. What is this? You delete first column, second row, take 2, 3, 0, 5. So, what is this? 10. Where? Here. So, we have deleted first column, second row. We have chosen 2, 3, 0, 5. 2 into 5 is 10 minus 0, which is 10. That is what we have written. Next. Similarly, find this. Delete second row, second column, 1, 3, 0, 5. Is it right? Second column, 1, 3, 0, 5. Okay, second row. What is this? 5 minus 0, 5. This value is 5. Similarly, second row, third column, 1, 2, 0, 0. The answer is 0. Fine. Next, this one, first column, third row, 2, 3, 2, 4, 8 minus 6, 2, okay. And this second column, third row, if you delete, so 1, 3, 0, 4, 1, 3, 0, 4. You take the rest of the elements as determinant, 4 minus 0, answer is 4. Next. What next? Third row, third column you delete. Take the determinant of 1, 2, 0, 2, 2 minus 0, which is 2. See, this is a cofactor matrix, all right. So, from this we can find what is adjoint. You just take the transpose, it gives the adjoint. Adjoint of A is equal to transpose of cofactor matrix. What is transpose? 10, 0, 0 and here minus 10 and here is 5 and here is 0. 2 minus 4, 2. Now we got adjoint, right? Use the formula to find A inverse. Therefore, A inverse is equal to 1 by determinant of A into adjoint of A. So, by this we can write A inverse is equal to 1 by what is determinant? 10 into adjoint of A. What is adjoint of A? 10 minus 10, 2, 0, 5 minus 4, 0, 0, 2. This is the inverse of a matrix. Next we have another problem. See, this is important, okay. This may ask for 5 marks. Here A is given, B is given, we have to show that AB whole inverse is equal to B inverse into A inverse. This is what we have learned in case of matrices. We have a particular theorem on this statement. So, for this first we are going to find B inverse and A inverse, then we can find AB whole inverse. See, for this what I am doing is I will take determinant of A first. What is determinant of A? 3725 is equal to 3 5 is 15 minus 14, 1. Determinant of A is 1 now. Similarly, determinant of B 6 8 7 9, which is equal to 6 9s are 54 minus 56 minus 2. Determinant of B is minus 2, remember. So, determinant of A is 1, determinant of B is minus 2. You remember that. Next, what we can do is we can find inverse of A and inverse of B. So, to find inverse of A, we need to find cofactor, right? Cofactor of A is equal to plus minus plus minus plus. Is it correct? Absolutely correct. Now, what is this? 5, 2, 7, 3. So, what is adjoint of A now? Adjoint of A is 5 minus 2 minus 7, 3. Similarly, cofactor of B plus minus minus plus. So, here 9, 7, 8, 6, all right. Now, you take to find adjoint of B, you just take transpose of this 9 minus 7 minus 8 and 6, okay. This is adjoint B. Now, what you can do is we can find B inverse into A inverse, right? B inverse into A inverse. What is the formula for B inverse? 1 by determinant of B into adjoint of B, okay. Into what is A inverse? 1 by determinant of A into adjoint B. So, which is equal to, what is 1 by B? Determinant of B is minus 2. What is adjoint of B? 9 minus 8 minus 7, 6. And adjoint of, determinant of A is 1. You can directly write down adjoint of A. Adjoint of A. Understand? Formula for B inverse and formula for A inverse. So, what is that? Adjoint of A, where adjoint of A here? So, 5 minus 7 minus 2, 3. So, you just multiply together and give me the answer that gives B inverse into A inverse. What is that? So, minus 1 by 2 into 9 5 is 45 plus 8 2 is 16. Next, 63 minus 63, 9 7 is 63 minus 24 minus 7 5 is 35 35 See, first row, first column, yeah, minus 35 minus 12, next 49 plus 18. So, what is the answer? That is equal to B inverse into A inverse is equal to minus 1 by 2 into, what is this? 7, 6, 67, 7, 8 minus 87, and this 7, 4 with minus 47, and this how much? 7, 6, 67, right? 49 plus 18. 49 plus 18 is 67. Okay. So, this is what B inverse into A inverse. So, this is what we got. B inverse into A inverse is 61 minus 87 minus 47 and 67 we got. 45 plus 60 is 61. we got it. Now this is B inverse into A inverse. Now we need to find AB whole inverse, right? So for this we have to multiply AB, we have to find AB, that is 3725 into 6879. So you calculate, so 3 into 6, 18 plus 49. Next, what is this? 8 3s are plus 63. Next, 2 6 are 12 plus 35, and this 16 plus 45. Okay, so now what you can have is 7 67 and 87 and 7 4 1 61. This is AB, okay. For this we have to find AB whole inverse. AB whole inverse 1 by determinant of AB into adjoint of AB. To find adjoint of AB, we have to find cofactor of AB. Cofactor of matrix A into B is equal to, so as you know that plus minus minus plus. So what is this? Here is 61, here is 47, here is 87, and here is 67. Adjoint of AB is equal to, take transpose of that, 61 minus 47 minus 87 and 67. This is adjoint of AB. Next we have to find determinant of AB. Determinant of AB is what? You take determinant of this, that is 67, 87, 47, 61. Oh, this is a big number. So calculate. So 67 into 61, 67 into 61 minus 87 into 47. How much? 4087 minus 4089. The answer is minus 2. Determinant of AB is minus 2. Now we can write AB whole inverse is equal to 1 by determinant of AB into adjoint of AB. So what is that? 1 by minus 2, adjoint of AB is here, as 61 minus 87, 47 and 67. Understand? Here we have AB inverse is minus 1 by 2 into 61 minus 87 minus 47, 67 is there, and the same way we have AB whole inverse also the same. Therefore we can say, you can call it as 2 and you can call it as 1. From equation 1 and 2 we can conclude that what we can conclude, AB whole inverse is equal to B inverse into A inverse. Understand? So this gives the proof of the statement through an example. Which is example? That the example they have given. This is how we can do it. So generally these questions are of 5 marks. Okay. So we practice on this. So definitely it confuses a lot. So kindly practice on it. Once you practice more problems, you will get familiar with it, so that you won't get more confusions. Next, this is also 5 mark question, which is important. So here the question is, the matrix is given and we have to verify this expression, and hence we have to find A inverse. Okay. How are we going to find that is, first I wanted to find a square. What is a square? A into a. Okay, what is a? 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2 into a. Again write down 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2, which is equal to, what is this? You just multiply 2 into 2, 4, minus 1 into minus 1 plus 1, plus 1 into 1 is plus 1. Okay. Next, 2 into minus 1 is minus 2, minus 2, minus 1. Next, 2 plus 1 plus 2. Understand? This into this, plus this into this, plus this into this. We got it. Next, minus 2, okay, minus 2, 1 minus 1 into 1, minus 1, okay. Yeah. Next is 1 plus 4 plus 1. Next, minus 1, minus 2, minus 2. Next, 2 plus 1 plus 2. Minus 1, minus 2, minus 2. 1 plus 1 plus 4. This is a square. What is a square? A square is 5, what is that? 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6. This is what a square. Similarly, find a cube. A cube is a square into a, which is equal to 6 minus 5, 5, minus 5, 6 minus 5, 5 minus 5, 6 into a. What is a? 2 minus 1, 1, minus 1, 2, minus 1, 1 minus 1, 2 is equal to, you multiply, okay, 6 into 2 plus 5 plus 5. How much? 10 plus 12, 22. 22. Similarly, minus 6, minus 10, minus 6, minus 10, minus 5. How much? Minus 11, minus 10, minus 21. Similarly, 6, 5, 10, 21, 6, 5, 11 plus 10, 21, 10 plus 11. Next, this one, minus 10, minus 6, minus 5, minus 21. This 5, 12, 5, 22. Next, minus 5, minus 6, minus 10, minus 21. Next, 10, plus 5 plus 6, 10 plus 5 plus 6, 21, minus 5 minus 10 minus 1, sorry minus 6 minus 21. Okay, let me repeat this, minus 5 minus 10 minus 6, okay, minus 11 minus 10. Next, 5 plus 5 plus 12, 22. This is what? A cube. Now we got a square, a cube, that is enough. Now what you can do is, you can substitute all the expressions what we have got here, you just substitute in that. What you are going to have is, okay, I will that equation will be equal to, what is a cube, and all those things will be equal to a cube minus 6a square plus 9a minus 4i is equal to, what is a cube? 22, okay, minus 21, 21, 21, 22, minus 21, 21, minus 21, 22. This is my a cube, okay, minus 6 times a square. So you directly multiply 6 times of a square. Where is a square? Here is a square. 6 into 6, 36. 6 5s are 30. Next, 6 5s are 30. Next, 30. Minus 30, okay. Six into minus 5 is minus 30. 6 into 6 is 36. And minus 30. And here plus 30, minus 30, plus 36. And next, what do we have? Plus 9a. You directly multiplied with 9. Multiply with 9. Multiply with 9a. Okay, what is this? 18 minus 9, 9, minus 9, 18, minus 9, 9, minus 9, 18, plus, what is there? Minus 4i. So I should take the order of I is also 3, and multiply with 4, it will become 400, 040, 004. Okay. Now what you can do is, I'll just simplify it, that's all. Simplify the above. What you can have, what we see, what you can do is, you add these two matrices and you can add these two matrices, because signs are similar with that. 22 plus 18, 40, minus 30, plus 30, minus 30, 40, minus 30, plus 30, minus 30, plus 40. This is what? This and this matrix addition. And with similarly, you can do with this minus of minus 36 plus 4, 40, okay. Already minus is there, don't consider this one with that. So minus 30 minus 0, what is that? It will be what? 30, minus 30 itself, and that is 30 itself. And what about this? Minus 30, okay. And what about this? 40, what about that? Minus 30, and here 30, minus 30, and here it will be 40, understand? Now you can add this too. What you are going to have is 40 minus 40, 0. Next, 30 minus 30, minus into minus is plus, minus 30 plus 30, 30 minus 30, minus 30 plus 30, 40 minus 40, minus 30 plus 30, 30 minus 30, minus 30 plus 30, 40 minus 40, all entries are 0, hence we can say it is equal to 0. Hence verified that a cube minus 6a square plus 9a minus 4i is equal to 0. Okay. This is how we verified. Now what we can do is we can find A inverse with that. Yes, just now we proved this expression. Now with this expression we can find A inverse. Okay. See, I can multiply A inverse post multiplication. Post multiplication means you multiply on right side of the each term. Okay. So now what you can do is, because determinant of A is not equal to 0, no, and that with that we can multiply A inverse. So A cube A inverse minus, I can write I cube as A into A, okay, A into A. Now minus 6 A into A inverse plus 9A into A inverse minus 4I into A inverse equal to 0. 0 into A inverse is 0. Okay. So with this I can write A into A. I'll group these two terms, that is A into A inverse minus 6A. I'll group these two, A into A inverse plus A into A inverse is I, as you know that, minus, if you multiply I into A inverse, it will be A inverse itself. A inverse is equal to 0. Okay. Now what is this? I into A is A square minus 6A plus 9I minus 4A inverse is equal to 0. So with this what I can do is, so I can write this. Understand? I send this term to other side, it will become plus. Therefore 4A inverse is equal to A square minus 6A plus 9 times I. See, with this I can write A inverse is equal to 1 by 4 times of A square. What is A square? 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6 minus 6 times A. What is A? 2 minus 1, 1 minus 1, 2 minus 1, 1 minus 1, 2 plus 9I. 9I is the directly you can write 900 090 Okay. See, with this we can write 1 by 4 of 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5, 6 minus, multiply this 6, 12 minus 6, 6 minus 6, 12 minus 6, 6 minus 6, 12 plus 900090009, which is equal to 1 by 4 times, so you just simplify, okay, 6 minus 12 is minus 6, minus 6 plus 9 is 3, okay, minus 5 plus 6 is 1, 1 plus 0 is 1, 5 minus 6, we are multiplying this minus with that and we are doing simplification, okay. 5 minus 6 is minus 1, minus 1 plus 0 is minus 1. Next, minus 5 plus 6, minus 5 plus 6, 1, 1 plus 0 is 1. Next, 6 minus 6 plus 9, 3. This minus 6 minus 5 plus 6, 1, 1 plus 0. Next 5 minus 6 is minus 1 plus 0 is minus 1. Next minus 5 plus 6 is 1, 1 plus 0 is 1. Next 6 minus 12 is minus 6 plus 9 is 3. This is what the inverse of the given matrix. Okay. See here we have done in a different method, understand. What we have done, we can recollect it. First what we have done, first we verified this expression. If this expression is verified, then we can find A inverse. The same problem can also solve by using elementary transformations, but the elementary transformations not going to ask in 5-mark question, and this question is going to ask in 5-mark question, that too you have to use the determinant concept. Okay. And one more method we have learned today, right? What is that? With this expression we got the A inverse. What is A inverse? How we have done? In this. And one more method is also there. What is that? That is finding adjoint matrix and determinant of a given matrix. With that we can use the formula as what is that formula? You can use this formula for this particular problem, 1 by determinant of A into adjoint of A. See, we are quite familiar with this formula, how to use and how to find adjoint A and how to find a determinant of A. These two things we learned today, and you can do it in that way also, it will give the same answer. So, with this we can completed the exercise 4.5. Okay. So, practice more examples from exercise 5 which are same. So, we have discussed all kind of problems from this exercise, and rest of the problems are which are similar to these problems. So, kindly sit and practice, so it will make perfect for your examinations. Till then, Sai Ram.